Welcome, everyone. Before we start, I would like to ask a question. How many of you are using daily Unreal Engine for your work? Okay, so majority. And how many of you are programmers? Also majority, great. That's a good talk. All right, so first, a disclaimer, you don't need to take pictures of the presentation because at the end there will be a QR code, so all the slides will be available for you. And then the second disclaimer, majority of the features are available in the Unreal Engine versions back to like 4.23, but some of them are only available in the latest one at this time, which is 5.4. This is the agenda for the talk. We will be covering 6 different topics. All right, so let's start with the Fname filters. Many of you probably have seen a declaration of a function like this many times, both in engine and your game code probably. And if you try to use this in Blueprint and call this function, this is what you see. And seeing code like this make me a little bit grumpy because there are 2 problems with this. First, whoever wants to use this function might just not know what kind of string you want to use. And second, there is a high chance that you will probably have a typo at some point, and it will be very hard to find. So what we can do about it? Well, we can go back to this function declaration and modify it slightly. We can use a uparam macro. We can use a meta tag. And the meta tag is get options. And then we say, what kind of functions we want to use, what function name we want to use to get the options for us. So in this case, we modified it and we want bar params to define the options for our name parameter. Now, what is bar params then? Well, it's a U function because it needs to be serialized. It's a static function. And finally, it's a function that returns array of names. And this is the definition of this function. It's very easy. It just has 2 names in it. It's a static function. It doesn't need to be. You can make it dynamic if you want. But in this case, to keep it simple, just 2 names. And then you just return it. So with these changes, if we run this code and try to use this same blueprint node again, this is what we get now. Instead of having just an input field that anybody can type just anything in it, we get a combo box. And then we can just expand it. And instead typing in, we have the 2 options, 2 strings we define in the function. Very nice. And this, of course, doesn't only work for functions and the parameters. It also works for properties. So same way, you just have a U property, then you do the meta get options, you define the function that returns the array of names you want to use it for it. And then this is the result then in the U properties. But I'm not going to judge you, but if for some reason you use names instead of gameplay tags, I don't know. So now let's talk about gameplay tags. They're great, but they can be sometimes kind of hard to manage as well if you don't use gameplay tag filters. So let's take a gameplay tag declaration, just like we did with the Fname. And if you try to use it, this is an example from Lyra starter game. You get all the existing gameplay tags in the game expanded. And how are your designers supposed to know what kind of gameplay tags they are supposed to use with your system? Well, they don't. That's the problem. Or they need either to ask you, or they need to go to Confluence or something and search for it, which is a problem. Luckily, somebody at Epic was smart enough to think about it and add something called gameplay tag filters. So again, let's go back to the declaration of the property, add a meta tag, categories, and then we say what kind of root gameplay tag we want to use to filter it. In this case, we say we want only gameplay events. And now if we run this code and open the editor, this is what we get. Instead of getting a giant list of all the existing gameplay tags, we only get the gameplay tags that we want from a specific category. So instead we want gameplay events, we get gameplay events. And once again, it's also working for parameters of a function, not just properties. So the same way, by default, if we just do we use gameplay tag as a parameter, this is what we get. If we modify it like this, so we just add uparam again, we have only gameplay events available. Now, an inline allocator. This is an array of actor pointers, something you probably made like hundreds, if not 1,000 times. But how many of you know that it actually takes 2 template parameters, not 1? Okay, some of you. The second parameter is actually an allocator, which you can define. So let's add one that is already existing in the Unrealengine source code, and it's called Tinline allocator. What it does is it allows you to create an array that will allocate enough space for the specified amount of elements, in this case it's 8, on a stack instead heap, given that the declaration of this array is also on stack. So for example, if you do it inside a function, all the elements will be added on a stack, not on a heap. But you don't have to worry about crashing your game if you exceed this limit, because if you do, like if, for example, you add the 9 elements in the declaration like this, it will just move all your elements from stack to the heap. So it's great. But why it's great? Why would you care? So before we answer this question, I also want to mention that tset and tmap also have inline allocators. They're called inline set allocator, just in case you were wondering. So for the example, let's create a struct with 3 properties, x, y, and z, and then write code like this. We create an array of nodes. We create a for loop that goes 1,024 times. Then each iteration, we just add 1 node, we fill it with dummy data, and that's it. And this is one function. Now let's copy this code, and the only change will be that we will add the inline allocator to it. And now I've also added the Unreal Insight macros to measure the performance, and this was the result. The version with the inline allocator took 2.8 microseconds to run, while the version without was 7.7, which is 3 times slower. But some of you might be wondering, okay, Robert, that's not really a fair comparison, is it? Because you just explicitly declared how many elements can be added to the inline allocator, because you said like there's 1,024 elements, so you could pre-allocate the memory, while for the version without inline allocator, it was growing multiple times, so it needed to reallocate a few times. That's why there is a difference. And you're right. So I changed the code, and I added the reserve call before going into the for loop, which pre-allocated all the required memory. And this is the result. With the version without reserve, result is the same. It's 2.4 microsecond and 6.7, which is roughly 3 times slower. But then with the version that has reserve, the result is slightly different. It's only 2 times slower, but it's still slower. And you might be wondering why. And my best guess, because I'm not 100% sure, is because the version without reserve call actually needs to go and find big enough space to allocate it on a heap, while the inline version is all it's doing is just it's moving the stack pointer. So it's literally like instant. It doesn't waste any time in finding spot enough to allocate your required memory. So that's one of the benefits. You just get extra a little bit performance, which can be like a dev by 1,000 cuts if you don't do it, because like why would you care for just 2 microseconds? You're right, that's just like nothing. But if you multiply it by a few hundreds, because we all do like for loops like this and temporary arrays multiple times in the game code. So you can save a little bit of time. But the second one is the memory fragmentation. If you do a lot of temporal allocation each frame, then at some point your memory will be very fragmented. And if you use a lot of inline allocations, at the end of the function, the stack pointer just gets popped, and that's it. So you get two benefits out of it. Now, next point is parallel for. I would like to present you again an example of a code that doesn't use parallel for, and then how easy it is to modify the code to run it in parallel. So we create a declaration, and we get an array of a lot of locations. Like, imagine this is a giant array of locations. Then we have another an array that stores some selected locations that will pass some conditions that we do in the for loop. So we get a for loop, we go through all of the locations, we process them, and then if it meets our conditions, we add it to the array, and that's it, right? A code probably most of you have written, like, again, hundreds of times. Very basic. So this is how you would modify it to run on multiple threads. Again, you get an array of all the locations, but now instead using an array to store the valid locations, you use a queue. Now this queue is operating on a specific mode, which is called MPSC, which stands for multiple producers, single consumer, which basically means that multiple threads can push the data into it, but only one can consume it. And then instead for loop, we use the parallel for, which takes two parameters. First one is how many times we want to execute this loop, which is for all locations. So just number of elements in the allocations array. And then it takes lambda, which will be executed for each and every element of the array. So we capture by reference the queue, the array, and then as a parameter to the function, we get an index. And then inside is the same. We just get the location, we do the processing, and we enqueue it. Nice and easy. Changing just a few lines, we got this code, which might look a little bit more complicated because of the lambda, but it's like in the end, it's really not. The body of the for loop is basically the same. So it's not that complex. And this is the, again, result in the Unreal Insights. So here is the game thread. And we have the parallel for task, which takes 2 milliseconds. And while the parallel task is running, it will block the game thread. But then below, you can see all those yellow and green bars are the background threads that are executing the tasks. So you can see the game thread at the top is waiting for all the background tasks to finish the job. Now, there is one very important note here, because I know some people, when see things like this, are like go back home and then replace all the for loops with parallel for, because why not? Like multi-threading is cool and we can get a lot of performance out of it. But problem with this is that you need to keep in mind that scheduling job, like work for a different thread and then synchronizing it takes quite some time as well. So we've seen in the previous point when I was talking about inline allocator, the loop that was executed 1024 times took only like 3 microseconds, right? And scheduling a work for a thread and then synchronizing it is like a couple hundreds microseconds itself. So the main takeaway is, if you think you can benefit out of using parallel for, then please do, but always measure before and after. Because it might be the case that you just go, replace it, and you end up with your game running much, much slower. So next one is deferred code execution. For this one, I would like to show 2 examples from 2 different languages than C++. The first one is Golang, which has a keyword defer, and we can use it, for example, the simplest example is hello world. So in this case, we have printline world, printline hello, but in the output we will see hello world in order because defer is deferring the execution until the end of the scope. So only at the end of the main function, it will actually execute the printline world. This is basically the same code, but this time in Odinlang. And now I will show you the C++ version, where, yeah, we don't have C++ version. But thanks to very smart engineers working at Epic Games, they came up with some C++ magic, and they created on-scope exit macro, which is, I even have a hard time reading the lambda they created there, so I don't exactly know what it's doing, but I know how to use it, so at least that. And to recreate the hello world example in Unreal Engine code, we would go like this. We call the macro on scope exit, then we open the scope, we specify the code we want to run, then we close the scope, and then we write the rest of the code. So this is the hello world again, but this time in Unreal Engine C++. Now you can obviously use this for many things. For example, deleting pointers, which is very convenient. You don't need to like do it at the end. You can do it right after you allocate the memory. You can deallocate it in the on-scope exit, and you don't have to worry that somebody will at some point go and add an early return to your function, and then you're screwed because you have a memory leak. Same goes for the closing handles to files. And really, sky is the limit. Whatever you want to do it with it, just do it. And the last point is Algo namespace. Well, this one exists in Unreal for, I don't know, like very, very long time. I checked like 4.23 and it was already there. And it's probably even older than that. And they are constantly adding more to it because some of the algorithms I'll be talking about are only available in, again, starting 5.2, I think. But I would like to cover one example specifically and then just mention few to let you explore on your own. So again, an example. Imagine you have an array of floats and you want to find the greatest flow in this array. So you get a temporary variable, you assign the minimum value to it, then you just iterate through the array, find the greatest one. If you found, reassign, and that's it. A few lines of code, and you have the greatest float. Now, you can replace all of that with just one line of code, which you can just call max element, which will return you the pointer to the greatest element of this array. But I hear you, some of you are thinking, the reality is how often do you have an array of primitives? In most cases, we have like structs or classes. We don't have primitives. No problem at all. There is, let's do another example with the struct foo that has 3 properties. And now we want to find greatest one from the array of foos. We could just use max element by, which not only takes the array as a parameter, but also takes a projection, which is a lambda that specifies which property you want to use to find the greatest element from it. So in this case, we specify we want to use an x property, and it will return the greatest foo, the foo that has the greatest x property. Then I would just like to mention a few others, which is accumulate, that lets you execute a specific operation on all elements of the array. For example, addition, subtraction, multiplication, whatever you want. Then there is binary search. So you have a sorted array. You can just call binary search. You don't have to implement it on your own. Then there is heapify. There is also heap sort. So you don't have to use quick sort or like bubble sort. There is random shuffle. The amount of times I was Googling and going to Stack Overflow looking for a random shuffle algorithm is insane. And it's like right there. You can just use it. There is reverse, which basically takes your array or the container and reverses the order. There's rotate, which takes n elements from the beginning of the array and pushes them to the end. Oops, sorry. And there is lower bound, which returns the first element that is greater than the parameter you pass. So yeah, there is, and this is just like few selected ones, and this namespace contains like, I don't know, a few dozens of them. So if you are looking for something like algorithm that operates on some kind of container, then just look at the algo space, because it's probably already implemented. So, and that's it. Here is a QR code. So it redirects you to the website, but it's not available just yet. When I get home, I will just upload it. So don't worry if it's not there yet. And that's it. Thank you. And if there are any questions, there's one. Do we have? I'm sorry, I can't hear.
Right now, okay. Have you ever, have it happened to you that you found something in Unrealengine that hasn't been documented in official documentation, or haven't been found in other forums, but somehow is placed in the code, like commented or something like this?
Many times. You can, it is very often the case when you dive deep in the code of Unreal, there's not mentioned in documentation anywhere else, but there's like a massive comment at the top of a struct or something. There's like, the first example that comes to my mind is, I think, F scoped task or something like this, which is a thing that shows the progress bar when you do something synchronous, and it shows you the progress bar. And it's like, it's nowhere in the documentation, but if you just go to the declaration, you can find the like massive multiple, like I think 100 lines of comment, like literally. So yeah, many times.
Okay, thanks.
No.
Okay, so with the inline allocator, I don't know if I got it correctly, but if you go over the amount that you declared in the template argument, does it grow on the heap? Like that's...
Yes, yeah. The moment you exceed the amount you specified in the template of the allocator, it takes all of the elements and reallocates them in the heap, and then every other element is also getting added to the heap.
Can you change that so it crashes?
You probably, I mean, it's open, you can modify the
Because
code.
this is also one of the useful cases, or like inlining and like having strict rules about how big your array can get, that you can reason about, okay, how many elements am I possibly processing in this function? Okay, so you don't know if you can change it, if it is like T inline crash allocator.
I don't think there is one, but I think it would be super easy to just add like ensure, and like whenever it happens, and it will cause, it wouldn't crash, but it would like cause a breakpoint. So every programmer that uses it, they will know that this happened.
Something like that.
Yeah,
Like,
yeah. So I think it will be like trivial to change.
There is another allocator for that called static allocator.
Oh, okay. Is there? Oh. What was it? What's the name? Stacking? Static allocator. Okay. Okay. No more questions. Then thank you very much.